Today we present NewsCLIPpings, our method for the automatic generation of out-of-context multimodal media. First, let's take a look at real-world instances of out-of-context images. Image A talks about Tom Cotton with gold bars, B talks about US senators sleeping, C talks about Jane Castor maskless, and D talks about trash from refugees. However, image A depicts a different military service member, not Tom Cotton. B depicts the UK House of Lords, not US Senate. The semantics are plausible, but upon further research, we discover the images depict completely different people and countries. C does indeed depict Tampa Mayor Jane Castor, but the photo was taken from a different time period. In this case, the person is plausible, but the context they are in is misrepresented. D does indeed depict trash left behind by refugees, but the photo was taken in Europe, not the US. In this case, the scene is plausible, but again, the context is misrepresented. Here we see actual samples from our NewsCLIPpings dataset that aim to capture these real-world tactics. A misrepresents Kylie Minogue's Taylor Swift, B misrepresents a march at a Native American reservation as Gettysburg National Military Park, C misrepresents Prince William in the context of the birth of his son when he is with unrelated young hockey players, and D misrepresents a parking lot as taxis blocking traffic. Here's an overview of our work. First, we present a dataset of automatically generated out-of-context images created by matching real-world news images and captions. Our dataset is built off of visual news, and the method we present can be applied to virtually any news dataset. Finally, we use CLIP, a recent state-of-the-art image retrieval model that we found to achieve 97% accuracy on a 5-way retrieval task, select the true image out of 5, showing that it is strong on the news domain. Now let's dive into how we generated our dataset. First, our semantic split queries for a specific semantic context with the intent to portray subjects as different named entities. We have a query caption, Angela Merkel speaking to Parliament. We have a set of candidates that do not depict Angela Merkel, and we select the most similar image for the query caption using the highest clip text image similarity. In our other semantic split, we now use the highest clip text similarity and select the most semantically similar caption. For our person split, we query for a person with the intent to portray them in a different semantic context. For our query caption, we only consider candidates that do depict Angela Merkel now. We then use the lowest SBIRT WK text similarity to drive the semantics apart. For our scene split, we query for a scene with the intent to portray a different event or context. For our query image, we consider a set of candidate images that portray different entities. We then use the highest score from a ResNet 50 model trained on Places 365 to retrieve an image with a similar scene. There exist a number of relevant datasets for the detection of multimodal misinformation. Some works are small in size, some exhibit linguistic biases, and some are largely unlabeled. We present a fully labeled dataset with virtually no unimodal bias with almost 1 million unique pairings. Here we report our experimental results for a classification task. Label each image caption pair as pristine or falsified. At inference time, we feed embeddings from the CLIP model, or VisualBERT, a transformer-based design, into a classifier. Here we see that unimodal models perform at near chance. We find that for multimodal CLIP, the semantic splits are the easiest, while the person split is the most difficult, and we see the inverse with VisualBERT. What's especially interesting is that VisualBERT performs comparably to CLIP, only on the person split. With a news pre-training corpus less than 1% of CLIP's training set size, VisualBERT demonstrates that semantics knowledge is most critical for our person split. On the other hand, all other splits tend to require more extensive knowledge of named entities. We also conducted a human eval on a 200 sample subset of our dataset that mixes samples from all our splits. For each image caption pair, we asked 5 Amazon Mechanical Turkers to classify it as pristine or falsified. We found the most optimistic human performance, at least one person gets it right out of 5, to be around 85%. The average human performance is comparable to CLIP's at about 65%. Our work demonstrates that automatically generated image repurposing on a large scale is now possible with off-the-shelf AI models. Our dataset tests entity understanding and semantic understanding. Our dataset can also be used to augment existing datasets for detecting images used out of context. Thank you for your attention. For more details, see our paper.